Sana lock na lang ako para i-kiss mo ko.
Oh my glob! Look at those luscious lips!
A brief history on locks. Locks have not always been the reliable modes of security they are today. Initially, they were only simple knots made from rope and were used only to see whether or not someone had tried to unlock them. Mechanical locks, however, were introduced in ancient Egypt about 6,000 years ago. Made entirely from wood and bolts, they had managed to create simple but effective pin tumbler locks which they used to lock their doors. I guess you could say they wanted some privacy. Wink, wink. It wasn't till 1st millennia BC that the Romans took into their hands the task of improving on these genius, albeit still quite crude devices. Having realized that even Greek locks were unsecure, the Romans had finally introduced metal into the picture. Iron, they realized, made for even sturdier locks. Time wards too were finally developed, so that only one key corresponded to a certain lock. Years later, more technological advancements have been made, thus ushering a new wave of lock innovation. Jeremiah Chubb, James Sargent, Samuel Segal, and Harry Seraph are only few of the many engineers who have brought us the most reliable lock mechanisms today. And so, we have these men to thank for many a safe nights at home and our lock treasures. Kaya kayo, don't take your locks for granted. Huwag maging lock key salayaw. Plastic holder. This serves as a binder for the keyway and the casing. Casing. This is the main body of the padlock. It houses the internal locking mechanism and keyway. In our case, the casing is composed of layers of stainless steels with different molds that correspond to the positioning of the internal components. These bolts are called rivets, and they hold the internal components and the casing intact in the padlock. The shackle locks or holds parts of the padlock, while the shackle spring is responsible for making the shackle move up and down in response to the latches. Tailpieces or latches are extensions connected to the back of the plug which actuate the shackle spring to lock or unlock the padlock. The shell or the housing contains 3 to 7, in our case 4 cylindrical chambers drilled from top down through the smaller circumference opening near the bottom. The plug is found inside the opening of the shell with an equal number of cylindrical chambers aligned directly with those in the shell. It is the inner piece of the lock that rotates upon insertion and tension of the correct key. The plug is connected to the cam as mentioned before. The plug rear protection plate serves as lock for the plug and the shell so that they won't get detached from each other. Key pins or bottom pins are pins that touch the key when the key is inserted. They come in different sizes to correspond to the various depths cuts on the key. Driver pins are pins in between key pins and springs. When in resting position, the driver pins block the rotation of plug. In more advanced pin tumbler systems, the driver pins may be sized to the inverse of the key pins to defend against decoding or comb pick attacks. Springs are placed above the pin stacks and push the pins down to their resting position to make sure that they can't be trapped above the shear line while the plug is in default position. The shear line is the line where the driver pins meet the bottom pins.
Okay, let's look at our first pin tumbler lock. I'm going to explain how they work, but first let's just cover the parts of the lock. This is the Bible of the lock. The Bible of the lock contains the springs and the driver pins. The driver pins sit between the Bible and the plug of the lock, the portion that would turn if the right key were in it. Below the driver pin are the key pins, so called because they actually touch the key. Each of the key pins will be a unique height, where the driver pins and springs are all the same. The unique heights of the key pin correspond to the unique cuts in the key. So that when the key is inserted into the lock, the top of the key pins and the bottom of the driver pins sit at what we call the shear line, the line that divides the Bible from the plug and the whole system can turn freely. And that's it. They're simple locks.